Hey guys, today what we're going to be learning is volume of a cylinder. So what we're going to do is watch these videos, and then when you're done, I would like you guys to either start the homework or the extension. I forgot what I assigned. So let's go ahead and bring this up. So while I bring up my slide, I would like you guys to bring up your notes. It's lesson 5.3a, and what we're going to be doing is talking about volume. So as this is bringing up, I want to remind you guys is volume is how much space an object takes up. So for instance, when we look at shapes, all these shapes that we're going to be looking at is 3D. So before, when we were looking at area, we were looking at like a flat surface, how much area a flat surface. We're going to look at how much area like is in the entire classroom, something like that. So what we're going to do is I'm going to skip a handful of these questions because I really want to focus on the idea of what is volume. So what I would like you guys to do is on the blank sheet of paper is just kind of visualize what volume is. So what volume is when we have a 3D shape, and these 3D shapes are going to be connected. And what changes the volume is the length of the volume, basically. Let me go ahead and finish drawing this so it'll make a little bit more sense. So if I were to connect all these sides, basically what it is when I stretch this changes the volume. The greater those black legs are, the greater volume, the more object this space takes up. So if I stretch this really far, you can see that it gets bigger and bigger and bigger. So I didn't add the leg back there, but you would notice that this is what it looks like three-dimensionally if I stretch it really big. Okay. Now we are focused on these rectangles, but today what we're going to be doing is looking at cylinders. So cylinders, what I want you to picture is like a stack of CDs, or like a soda can, a soup can, and what we're going to do is look at the formula to figure out how much space these take up. Now I want you to realize is we are dealing with circles, so we got to think about the formula of circles that we've learned in the past. And we're going to review those if you guys forgot. So just as a quick reminder, as I set this up, this would be a cylinder, and what we are going to do is focusing on the volume, or how much area this cylinder takes up. And you can tell when I shrink it, it's less space, or if I stretch it, it takes up a lot more space. So let's go ahead now and explain how to find a volume of a either a prism, which is a rectangular prism is basically when you have two sides that are equal and parallel, and a cylinder. Now it says volume equals the base times the height. I want you to notice this is a capitalized B. This is saying the area of the base times the height. So make sure we write that down. So it says explain how the formula volume equals area of the base times the height that helps you find the volume. What does the B and the H represent? So it's basically what are the steps of solving this? So the first step is find the area of the base. Second step, multiply area of base by height of object, height of shape. And then don't forget, you want to put your answers in units cubed. So for instance, make sure your units are cubed. So for instance, what do I mean by that? That means if you get a final answer of like 15 centimeters, you want to make sure there's a cube on the centimeters. We're dealing with 3D objects, and so that 3 just makes it realize that's a 3D. So similar, if you get an answer as 14 inches cubed, make sure you put the 3 on the exponent 3 on inches. Remember, we are dealing with 3D objects, therefore we need a cube for our units. All right. So what we're going to do now is we are going to look at some shapes and find the volume of these. So first thing is you want to identify your base. And my base here is going to be a rectangle. Now looking at this, since it's a rectangle, I'm going to draw some dots back here to help us visualize parts of this. So this blue line represents the back of it. That's really bad. Let me go and fix that. Alright, so not the best drawn, but I want you to realize that's the back of the shape that we can't see. If this side length's 4, this side length's 4, this side length's 4. So it's saying what is the volume, what is the area of that bottom rectangle? And what that would be is 11 times 4. 11 times 4, and that is 44. Now it asks, what is the height of the figure? This is my height right here. It's how tall is my shape. It's 14 inches. So now, what we need to do is we need to multiply the volume of the base, which was 44, times 14. And you guys can take out your calculator. I'm going to go ahead and take out mine right now as well. And I'm just going to do 44 times 14. And that's going to give me an answer of 616. Now don't forget, this is volume, so it's going to be inches cubed. And that's going to be my final answer for volume. So let's go ahead now and look at the next one. This is a triangle. Now I want you guys to realize we are looking for the base. The base isn't always necessarily the bottom. The base is what two sides are congruent and are parallel, which means if they extended forever, they wouldn't intersect. So if you looked at mine right here, let me go ahead and bring up this tool. This is going to be the back of the triangle right here that I'm about to draw. So right here, guys, this is like the 3D version of it. You can't really see it because it's in the back. That would show you that this back triangle and this front triangle are parallel. Therefore, those are the parallel signs, okay? So what I need to do is find the shape. So this is a triangular prism. And what I need to do is find the area of the base. Remember, area of the base is the sides that, you have two sides that are congruent and are parallel. Those are the triangles. So area of a triangle is 1/2 base times height. When I plug these in, it's going to be 1/2 6 times 6, and 1/2 of 36 is 18. So that's my area of the base. So now I look at the height of my figure. The height is the height of my base, which is 6. So I'm going to have 18 times, so it says the height of my figure is 6. So to find the volume, I'm just going to do area of the base. So remember, it says volume equals big B times H. Big B just represents area of the base. So volume equals 18 times my height, which is 6. So we're going to do 18 times 6, which means it's 108. Now don't just write 108 because that's the biggest mistake I made. You must write millimeters cubed. Don't forget your units. Okay, so let's go ahead now and look at the next thing. We have another triangle. So like I said, just because you don't have the base as the bottom, you would have another triangle right here. And the one I drew in blue and the one that we can see here are parallel, and they are also congruent. So shape of the base is triangle. Area of the base, it's going to be 1/2 base times height. It's going to be 1/2 of 9 times 12. So it's going to be 1/2 of, I believe it's 108. Yes, 108. And if I divided that by 2, or took half of it, that would just be 54. So that's the area of this base. Now what I'm going to do is multiply it by the length. That's how long the shape is, and it's 18. So my height is 18. So I'm going to do 54 times 18. So when I multiply these two together, I'm going to have 54 times 18, which equals 972 centimeters cubed. Okay? Alright, so let's go ahead. We got, I think, just one more of these. So what we are going to do now is we are going to look at this shape. This is called a trapezoid. So shape of the base is a trapezoid. So some of us might have forgot the area of the base. It's basically we are taking the average of the parallel sides, that is 17 and 23. So to take the average of that, the formula is base 1 plus base 2 all over 2 times the height. That is just the area of this shape. So I'm going to have 17 plus 23 all over 2. That will be 40 all over 2, which is 20. Now don't forget, I need to times this by the height. I'll erase this so we can see it a little better. The height of the trapezoid is 20. So I'm going to put times 20, times 20, times 20, which means the area of the base, 20 times 20 is 400. Now guys, I know that this is the base and not any of these rectangles is because I have two congruent trapezoids and they are parallel. None of these other sides are congruent and parallel. So now what we're going to do now is look at the height, which is 19. And what we're going to do is take 400, which is the area of the base, area of the trapezoid, and I'm going to times it by the height. And I know it's going long ways, but that is the height. And I'm going to get my answer. So I'm going to have 19 times 400, and that's going to give me an answer of 7,600 centimeters cubed. Okay, so hopefully this idea of finding a volume of a shape makes sense, because now what we're going to do is we're going to focus on cylinders. So the example that I had us skip was finding volumes of pools. What we're going to do is find volumes of these pools as well. And what it's saying is use what you know about the volume equals base of an area times height to fill in the missing information of a pool. Each unit represents 1 meter. Round your answer to the nearest tenth. So what we're going to do is I want us to look at this shape of a pool. Here's my pool. And what we are going to do is find the volume of this. So first thing what we're going to do is find the area. So remember, it's area at the base, and now we're dealing with a circle. So area of a circle is pi radius squared. As a quick reminder, guys, the radius goes from the edge of any part of the circle to the very center and then stops. You're also going to hear words called diameter. Diameter goes all the way straight across from edge to edge and crossing through the center. So right here, this orange is the radius because it goes from the edge to the center, and this is 1 meter long. So what we are going to do on all these now, we're going to find the volume. Similar to the shape I showed you before, it's basically saying we're looking at this pool, and it's a circular pool, and I'm just trying to figure out how deep it is. So it says, well, what if the volume was 1 meter? What if it was 2 meters, 3 meters, 4 meters, 10 meters? That's what we're trying to figure out, is what is the total volume here. So as a quick reminder on all of these, we're going to do pi r squared times the height. Now one more thing, guys, I want you to realize it says round your answer to the nearest tenth. We're going to do two things. We're going to have our answer in terms of pi, which means we just have this symbol pi attached. And then we're going to have a second answer that's a little less accurate, where we're going to multiply by 3.14. So let's go ahead and find the area of the pool, just like the surface, the top of it. We're basically just finding this part right here of the pool. So that's going to be pi 1 squared. That is going to be 1 pi. This is my answer in terms of pi. It's really accurate, but now I'm also going to exchange pi for 3.14. So I'm going to have 3.14 is the area of the circle. So I'm going to have 3.14 times the volume, which is 1, which would give me an answer of 3.14. Area of the base times the height. Now we're going to do 3.14 times 2, because that's my depth. That is 6.28. Then I'm going to have 3.14 times 3. This would give me 9.42, I believe. I need to put this one in the calculator. 3.14 times 3 equals, yes, 9.42. And we're going to have 3.14 times 4. And that's going to be 12.56. And then 3.14 times 10, which is 31.4. Don't forget, all my units here are going to be meters cubed.